I'm the statewide UIC Underground Injection Control Coordinator for Department of Ecology. So I'm in charge of reviewing and rule authorizing all UIC applications, registrations that come in. Probably about 90% of those are stormwater related. Another 10% are remediation related on different types of contaminated sites. While I'm relatively new to ecology, I've been here about 8 months. I've worked as a environmental consultant in Western Washington over the past 24 years, doing environmental assessments, remediation oversight work, and also some construction stormwater permitting. And today we're going to talk about how underground injection control wells are used for stormwater management in the state of Washington. So stormwater management in Washington state, it can be under either the UIC program that retains all of the runoff onto the site, or it can be managed under the National Pollutant Discharge Elimination System through Ecology's stormwater permit program, through the use of stormwater general permits. The different stormwater general permits include construction, industrial, municipal, sand and gravel, and boatyard. And when we look at the UIC versus the MPDS systems, the UIC program borrows the design, construction, operation, and maintenance BMPs from the stormwater program to fulfill the all known, available, and reasonable methods of prevention, control, and treatment, otherwise known as ACART, requirements of the UIC rule. Now, ACART, it represents the most current methodology required for preventing, controlling, or abating the pollutants associated with the discharge. The concept of ACART applies to both point and non-point sources of pollution. The term best management practices typically applies to non-point sources of pollution and is considered to be a subset of the ACART requirements. And when we get talking about the UIC rule, it's 173218 WAC, underground injection control. And the guidance for UIC wells that manage stormwater was developed in 2006. These guidelines were later incorporated into the stormwater management manuals for both Eastern and Western Washington. And currently, volume 1-4 of the 2024 SWIM for Western Washington includes these guidelines. And for Eastern Washington, it's in Chapter 5 of the 2024 SWIM. Some of the requirements for use of UICs is there's no thresholds or minimum disturbed area for sites when UICs are used. There's also a requirement to retain all runoff on site, and this is from the modeled 100-year storm. And there's also requirements to treat and infiltrate all runoff. And there's some things that are not addressed by the SWIM's UIC program guidelines. And this includes UIC wells that receive fluids other than stormwater. That's not managed under the UIC program. And this precludes accidental spills or illicit discharges to the stormwater system. Also not addressed is the infiltration capacity of the vadose zone below the UIC well, or the ability of the UIC well to meet local operational requirements to infiltrate a certain volume of water in a given amount of time. And I want to stop now in this section to see if anybody has any questions before moving on to the next slides. One example, yeah, one example are sites that are undergoing remediation, contaminated sites where the material being injected is actually there to treat residual groundwater contamination. Other times, UICs may be used to discharge different types of, I guess, process waste, industrial wastewater, but that usually requires those discharges to be permitted through a state waste discharge permit. But those are a couple of other instances or substances that can be discharged through a UIC well. And I have a question in the chat. If the infiltration capacity of the vadose zone is not addressed in the SWIM UIC program, is it addressed elsewhere? Yes, it would be addressed in a discussion of the actual BMPs. I think it's going to be in volume 5 of the SWIM. I can't remember if that's in. There might be different volumes and chapters in the Western Washington version and the Eastern Washington version, but that's where the infiltration capacity would be assessed. The UIC program is mainly looking at making sure that discharges meet the non-endangerment standard for groundwater, which will be discussed in the next set of slides or upcoming set of slides. So what is a UIC well? A UIC well, or underground injection control well, means a well that is used to discharge fluids into the subsurface. And I kind of want to make a distinction that it's the subsurface means the unsaturated soils beneath the base of the well. UIC wells typically do not discharge directly to groundwater. Otherwise, they would not be able to be rural authorized. They would require a state waste discharge permit. So a UIC well can consist of one of the following: a bored, drilled, or driven shaft or dug hole whose depth is greater than the largest surface dimension, an excavated hole whose depth is greater than the largest surface dimension, an improved sinkhole, or a subsurface fluid distribution system, which includes perforated pipes, drain tiles, or other similar mechanisms intended to distribute fluids beneath the ground surface. Examples of UIC wells include dry wells, drain fields, infiltration trenches, if they include a perforated pipe, storm chamber systems with the intent to infiltrate, French drain system designed in part to discharge surface water to the ground, and bioretention systems intending to infiltrate water from a perforated pipe below the treatment zone. This slide shows kind of some examples of the UIC wells. Over on the left, we have almost like a modified dry well, and then we have in the center a version of the dry well before it's put into the ground. The upper right's an infiltration trench that includes a perforated pipe, and on the lower right is a chamber system. These are becoming more common under parking lots of commercial properties where they want to maximize the footprint of the development, and they don't want the drainage area to, I guess, include areas of the property that can either be parking lots or buildings. And these types of wells are termed Class 5 UIC wells, which are wells that are used to manage stormwater, and the majority of these are less than 20 feet deep. And here's another example of a storm chamber system where you've got the treatment zone where it comes in from the surface and goes to a conveyance zone, and then it's distributed out laterally to, uh, and then the the system is, the chambers themselves are designed to be more efficient than, say, just a gravel filled excavation. And this slide shows an example of a UIC dry well with a sediment control structure located upstream. Oh, and I see a question in the chat. Is a storm chamber called a UIC well, even though it is wider than it is deep? The main reason why we include storm chambers are they include an assemblage of underground pipes intended to distribute surface water. So that's the reason why they get lumped into the category of UIC wells, because these are kind of, I guess you would call them open bottom pipes, but they are still a system that helps distribute uh, the surface water runoff or the stormwater runoff. And this slide kind of shows a cross section of a typical UIC well system. In this case, we have a vegetated pre-treatment zone where the water goes from there into a sediment control structure. And then you have the flow going into the well itself. And these are typically, the base of the well is above the seasonal high groundwater zone. And typically on a lot of the shallow UIC wells, they discharge the stormwater above a confining layer. So this is a clay confining layer. And I want to go over some examples of things that are not considered to be UICs. Buried pipe and or tile networks that serve to collect water and discharge that water to a conveyance system and to surface water. So it's not being conveyed to the subsurface. Also, surface infiltration ponds and flow dispersion stormwater facilities. And those are primarily because they're, I guess their surface diameter is greater than their depth. Also, infiltration trenches that do not contain perforated pipe or a similar mechanism. And another category of materials that are not are permeable pavement. This includes porous asphalt, pervious concrete, and permeable interlocking pavement and aggregate pavers. In almost all circumstances, the surface diameter or width of these structures are much greater than the depth. And that's one of the reasons why they are not considered to be UICs. Yeah, they can be, there's some exclusions to or exemptions for those types of systems. And those types of systems would require a permit. So they would not go through the UIC program for rural authorization. Now I want to talk about the rural authorization requirements. The first requirement is registration of UIC wells with ecology. And there's two types that are coming in. One are new wells, and new wells are considered to be constructed on or after February 3rd of 2006. And these must be registered 60 days prior to construction. And that gives ecology enough time to do a proper review of the registration materials, and also in some circumstances to be able to notify other uh, interested parties. A lot of times it could be different types of water purveyors, and if the UIC well is located within one of their wellhead protection areas, depending on the type of facility, they will require notification. And there's also other category of wells. These are older existing wells, and these are considered to be constructed prior to February 3rd, 2006. And when those come up or become aware of, they should be registered with ecology as soon as possible. So the first requirement of UIC rule authorization is registration. The second is that the discharge from the UIC well must meet the non-endangerment standard to protect groundwater quality. And by non-endangerment standard, that means to prevent the movement of fluid containing any contaminants into the groundwater if a contaminant may cause a violation of the water quality standards for groundwater. And this can be done by applying stormwater BMPs, which are considered a cart for the wells to meet the non-endangerment standard. This also includes a separation distance between the UIC well base and the top of the seasonal high groundwater level. This is a zone where some additional treatment may occur. The UIC program also has prohibited activity discharges, and these are primarily limited to or associated with industrial properties, automotive repair, and automotive recycling, vehicle crushing operations, any type of activity that would have a high risk of petroleum releases or other types of contaminant releases that could get into the surface water and then into the UIC and potentially contaminate groundwater. Also, the UICs need to meet local ordinances, and some municipalities may have some restrictions on where UICs can be sited, and this might be restrictions related to critical aquifer recharge areas. What that could limit the depth of the UIC or the type of sites that UICs may be allowed on. And one thing I want to add about the separation distance, typically the standard separation distance is 5 feet beneath the bottom of a UIC well in the seasonal high groundwater. When we're talking about residential downspout infiltration, then we're just looking at least 1 foot of separation distance between the base of the trench and the seasonal high groundwater table. And the reason why we allow less separation distance for a residential downspout is the residential roofs are considered to be a non-pollution generating surface. And the third thing is if these two requirements are not met, then a state waste discharge permit would be required to operate the UIC well, or as an alternative, a different type of stormwater management system would be needed. Potentially a connection to a local MS4 or municipal system. There are also some exemptions from UIC registration. UIC wells at single-family homes or duplexes receiving stormwater runoff only from residential roofs are exempt from registration. UIC wells are used to control basement flooding because then you're looking at a shallow groundwater issue is what's getting into the UIC well and not stormwater runoff from a potential pollution generating surface. Also, storm drain components that contain perforated pipes but are intended to convey stormwater to a surface water body. Then other non-UIC wells include infiltration ponds, dispersion systems, or infiltration trenches that do not contain perforated pipes. And there's a couple of different ways to or approaches to meet the non-endangerment standard for new UIC wells. One approach is called the presumptive approach. And this presumes compliance with the non-endangerment standard when applied BMPs, including the potential treatment capacity of the vadose zone beneath the UIC well, are expected to eliminate or reduce concentrations of the pollutants concerned. Now, this approach may not be used when none of the source control or treatment BMPs in the manual are expected to eliminate or reduce pollutant concentrations. And these are typically higher risk sites with greater potential for petroleum product or hazardous chemical releases. And then you're looking at the second approach is the demonstrative approach. And this approach must address the following topics: a site-specific analysis of pollutant loading, including a risk assessment of down gradient and adjacent drinking water sources. It also includes a site-specific analysis of the treatment capacity of the vadose zone, BMP selection process used must be described, and also the pollutant removal expected from the selected BMPs. Also, there's a technical basis supporting performance claims for the selected BMPs and an assessment of how the selected BMPs will comply with the state groundwater quality standards and satisfy the ACART requirements. And for meeting the non-endangerment standard for existing wells, and again, these are wells constructed prior to February 3rd of 2006. We ask that UIC registrants complete a well assessment to evaluate the potential risk to groundwater from the use of the UIC well. And that would include the following: description of the land use activities around the well, the local geology, an assessment of the depth to groundwater table in relation to the UIC well base, and an assessment of whether the UIC well is located within a groundwater protection area. We also ask that they either create or provide an existing stormwater pollution prevention plan and this is more common on industrial sites that have petroleum product or chemical storage areas. We want to know what source control BMPs are in place to help ensure that impacted stormwater is not making its way into the UIC wells. And there's also some requirements for meeting the non-endangerment standard for municipal sites. And I want to say that the UIC program rules apply to Class 5 wells that receive stormwater regardless of whether a UIC well is located in a municipality permitted under a Phase 2 or Phase 1 or Phase 2 municipal stormwater permit. Also, when the overflow or discharge from a UIC well drains to a MPDS municipal separate stormwater system, the MS4 permit does authorize the discharge from the UIC well, but the UIC well must be registered and rural authorized or have a state waste discharge permit. This happens when the UIC well is designed to only infiltrate, say, 50, 80, 90% of the water, and the overflow goes to a different system that discharges to surface water. The UIC wells also must be included in a stormwater management program. And if there is no stormwater management program for that municipality, the municipalities must conduct a well assessment and create a stormwater site plan for the area served by each municipal UIC well. There is also a requirement of notification of water purveyors. The water purveyors have been requesting notification of all UIC wells prior to the construction for UIC wells that are located on properties within their wellhead protection areas. Because of this, the UIC program will request that the UIC registration applicant notify the water purveyors and provide documentation of the notification as a condition for obtaining rural authorization. And when applicants go on to the UIC registration app, there are links to the Department of Health source water mapping site that will show on a zoomable GIS map where the different wellhead protection areas are across the state of Washington. And the applicants just can put in their address of the site and find out whether or not their UICs are located within a wellhead protection area. And the Department of Health mapping application also includes links to the actual water purveyors in order for the UIC registrant applicant to be able to contact them. And we typically ask that people do this notification via email, and then they can upload a PDF version of the email to the UIC registration, and that would suffice for the notification. And one other thing I want to talk about is have a different type of a UIC well, and these are termed deep UIC wells. And one of the conditions for this is the well extends below an upper confining zone and discharges to an underlying vadal zone. So the example on the left shows the well penetrating the lodgement till layer and discharging into the advanced outwash. And these wells are these are almost always drilled. They can be 2 to 3 feet in diameter. They're typically backfilled with pea gravel. Some versions of these wells may include a conveyance pipe in the center of the drill borehole. And they also include a piezometer for water level monitoring. And these are typically used at larger area sites where there's the surface materials the till or silt, clay-rich soils don't allow for enough infiltration for the volume of runoff being generated. And because these wells penetrate the upper confining zone and discharge into the underlying outwash zone, which is typically where municipal water wells may be screened, there's additional requirements for these wells. And these are discussed in volume 1-4.15 of the Stormwater Management Manual for Western Washington, and they're also discussed in the manual for Eastern Washington. And I want to go over kind of a list of some of the requirements that are in addition to the shallow stormwater UIC wells that we've been talking about. It requires completion of a hydrogeologic study. It requires an O&M manual and a landscape management plan and a listing of source control BMPs. There is also a minimum requirement of a 15-foot separation distance between the base of the dry well of the deep UIC well and the surface of the seasonal high groundwater table. This is in excess of the 5-foot separation distance for the shallow UIC wells that discharge above that confining layer. There is also a requirement for documentation of notification and summary of discussion with down gradient and adjacent water well owners. This is also an additional requirement from the shallow UICs that only require notification and not a summary of discussion. And these are for deep UIC wells that are located within mapped wellhead protection areas. There is also a sealing requirement of any impermeable layers that are penetrated during the drilling and completion of a surface seal. And these deep UIC wells may be subject to prohibitions and additional conditions if they are located within wellhead protection areas. There are some municipalities in the state that have a limitation on the depth of UICs. Primarily, they say maintenance requirements. So some of them have a maximum depth of 20 feet. And that 20-foot depth is based on the assumed depth that a vacuum or Vector truck can operate to remove sediment buildup from the base of the UIC well. And I want to talk now about how the UIC treatment is determined. So we're basically looking at land use and pollutant loading evaluation. Land use is screened from insignificant to high based on, or pollution loading is screened from insignificant to high, and it's based on average daily traffic. And then we look at the Vado zone treatment evaluation. And that's rated from none to high treatment. And that depends on the geologic material type, the saturated hydraulic conductivity, absorption, capacity of the soil, cation exchange capacity, and the thickness of that soil, unsaturated soil zone above the water table. If the thickness is less than required, then no treatment is considered to be available. And we use the pollutant load and Vado zone classification to determine the level of treatment specific BMPs from the stormwater manuals. And I'll go into more detail on the next few slides. So this slide is kind of it gives you a description of the Vado zone treatment capacity for high and medium rated materials. So the high treatment zone capacity. That's related to more when you've got clay-rich soils, silt-rich soils. Uh, and these soils generally have a higher cation exchange capacity and a lower saturated hydraulic conductivity. So you're basically getting, slower movement of the stormwater through the soil zone, and you're getting a higher level of treatment. And these soils can also have a higher organic content, which will help filter out petroleum hydrocarbons. And then when you get into the medium uh, uh, treatment zone capacity, then you're getting less silt and clay, and then you're getting more into the different types of sands. So you're looking at a little bit higher hydraulic hydraulic conductivity, a little bit lower cation exchange, and a lower organic content. And then as you go down to low and none, you're getting into gradually coarser sands and gravels with no cation exchange capacity and no organic content. And when you're getting down to a category that has none, you're looking at gravels and cobbles, basically. So then we're also looking at the pollutant loading classification. And this is for solids, metals, and oil in stormwater runoff directed to UIC wells. So if you're draining a surface that isn't subject to vehicle traffic or application of sand or de-icing chemicals, then you're looking at a insignificant classification. An example of this would be an unmaintained open space. And then also under insignificant would be different types of roof systems, as long as they are not commercial or industrial with vent systems, or with different types of industrial roofs that may have different types of coatings that could be a risk of contaminants. And then when you get into, as you go from low, medium to high pollutant loading, you're basically just looking at increases in the amount of traffic. And one thing I kind of want to note is when you get into the high category, then you're looking at additional treatment and potential for removal of oil. So we look at, the vadose capacity, the pollutant loading classification, and then the next slide, we get to the matrix of determining what type of treatment is required for solids, oils, and metals. So when we're looking at pollutant loading classification of insignificant, a two-stage dry well is sufficient. And this is basically either a dry well or an infiltration trench with a perforated pipe that includes a sediment control structure. And then as we move up in pollutant loading and potentially down in treatment capacity, we're looking at a requirement of pre-treatment. And pre-treatment means the removal of 50% of total suspended solids. And then as we move upward in loading and a decrease in treatment capacity, we have a requirement for removing solids. And that's a 80% removal of TSS. And then, like I said before, on high use sites, there's a requirement for removal of oil. And this can be accomplished through a bioinfiltration swale at perhaps lower categories of high use, up to requirements for oil water separators at sites that have really high traffic loads. And this kind of concludes my presentation, and it kind of gives a good run through of what the UIC program is looking at when we are reviewing UIC registrations. And I kind of want to open it up to anybody that might have some additional questions. Yeah, you basically, there's a UIC closure form that can be downloaded from the UIC registration app. And that just needs to be filled out and submitted. And then we can close that well on our database or change the status to closed. And then there's some requirements for proper, I guess, decommissioning of the UIC well, and that's uh, discussed in the UIC rule. Okay, then I've got another question of what action should cities take if they suspect they have UIC wells that do not meet the standards? Uh, I think one thing it would be to look at if they don't meet the standards, uh, what we would probably be asking, because a lot of the existing wells were constructed before uh, the current requirements were in place. So then we look at having them do a well assessment and then look at the potential, pollutant loading potential of the site. And if it still looks like the UIC wells would not meet the non-endangerment standard, we'd be looking at if there's anything that they can do to retrofit the UIC wells, be it a dry well or an infiltration trench. But that kind of assessment comes down to a site by site, well by well basis. Because if we have registrations that come in and sometimes uh, we'll do a roll authorization, but we'll do a follow-up inspection and there's a different type of pollutant loading going on, and we'll have to require that the applicant or owner do a retrofit, potentially adding additional treatment or doing some type of source control or rerouting of stormwater runoff from an area that might have some high pollutant loading. Oh, and these would be privately owned UIC wells. Ah, then it's kind of up the responsibility of the owner operator of the well. So the the UIC owner or the property owner, it'd be their responsibility for uh, registration. And I don't know if there'd be anything a local municipality could do uh, on their end for notification, because a lot of times at ecology we would be completely unaware of where these wells might be located or the condition they're in or the type of drainage that uh, they have. Oh yeah, what will you be looking for from water purveyors in their review or request? Uh, be looking at some in some localities, municipalities, there's requirements for uh, a basic treatment, minimum requirement for all UICs if they're located within a well protection area, regardless of their treatment capacity of the Vado zone or the pollution loading. It's just kind of written into their either critical areas ordinance. So that's what we'd be kind of, looking for some feedback on that. And then just a lot of times the water providers just want to know, get an inventory of what types of UIC wells are going to be going in. And I know they like to get notified before construction and not after construction, because then there's not much that they can do, or it gets a lot more expensive and difficult to perhaps add additional treatment to meet that basic treatment requirement. And I have to admit, I don't know all the local restrictions or requirements, across the state. So that's where we're kind of relying on the local water purveyors to be able to weigh in and give their feedback.